Free body diagrams, video 4. This is the exact same situation as video 3, but we're going to add friction this time. So I'm going to start out with my dot for my mass. I'm going to look to see what's touching the mass, and the first thing I see is me, or a hand reaching in, grabbing it and pulling it up the incline, or trying to pull it up the incline. We don't really know which way it's going yet. So I'll draw it here at the angle that it's shown. And the other thing that's touching this mass is the surface. And a surface can interact two ways. It can interact with the normal force, and it can interact with the friction force. And we need to know now what's happening to this mass before we can draw in our friction force. The mass might just be stationary, or the mass might be big enough and the angle might be big enough and the force F might be small enough that the mass is actually sliding down the incline, and F is just kind of slowing it down as it slides down the incline. We don't know because no numbers are given here. So let me just tell you that the force is big enough such that the mass is sliding up the inclined plane. So if the mass is sliding up the inclined plane, then the force of friction is going to be down the inclined plane. We usually use a lowercase f for the force of friction, and since this mass is moving, we call that kinetic friction. I'm going to put a little k there. That's kinetic friction between the mass and the surface. So I've got the force, the hand reaching in and pulling up. I've got two forces for the interaction between the mass and the surface, a normal force and a friction force. And for the friction force, you have to know what direction the mass is going. And that's everything that's touching the mass. The only thing that can reach in from a distance is gravity. So there's the weight of gravity. Now, personally, I like to kind of rotate this over. Again, always choose one of your directions as being in the direction of the acceleration. So I told you F was big enough to cause this mass to go up the incline. So we know the acceleration is going to be in that direction. So I'm going to choose one of my coordinate systems to be in that direction, and the other one will be 90 degrees to that. So I'm going to redraw my picture. I've got a force, I've got a normal force, I've got a friction force, I've got a weight in the y direction, and I've got a weight in the x direction. So you have to go through, you can look at the previous video to see how you break up the weight. The weight in the y direction is going to be W times the cosine of theta. The weight in the x direction is going to be W times the sine of theta. And so we have two forces acting down the inclined plane. We have friction and the weight in the x direction. We have one force acting up the inclined plane. That's the force of us pulling. And then we have these two forces, the normal force and weight in the y direction, that are acting normal to the inclined plane. So that's the way I like to think of it. I like to have all of my vectors drawn with their tails on my object, so when I'm writing out my equations later, I go back, my eye immediately goes to my object, and I can see I have three forces in the x direction and two forces in the y direction, and I make sure I include those.